Okay, so in the last video, we talked about the radius of curvature, the equation, mathematical equation for that. And what was the equation? We know that R is equal to 1 plus dy by dx, the first derivative square, the whole raised to 3 by 2, divided by d square y by dx square. So this is the equation for it. So basically, you can understand that this numerator part, it cannot be negative, right? So depends on this value. So as you can see, I'm not taking the modulus of it, but depends on this value. So whether the radius of curvature is negative, R is negative or positive, we can understand. Okay, let's talk in detail. So let's say I have a curve here. Look at this. So this is a curve. Okay, or this is my curve. So here I'm going to find out the radius of curvature at this point and radius of curvature at this point. So I'm trying to explain this idea, and I'm trying to connect this idea with our maxima minima condition as well. So what I'm going to do is, let's say this here the radius is this, and here the radius is this. And I'm going to find out, see, this d square y by dx square at these 2 points. Okay, let me consider this one first. So here you can see what is the thing, d square y by dx square. The second derivative is actually, the second derivative is less than 0. So what does that mean? The radius of curvature is less than 0. In the sense, it is you can see that is negative. So the point is, you can get that point whenever the second derivative was 0 and the first derivative was like, second derivative was less than 0 and first derivative was 0, but that was also the condition for maxima. So if the first derivative dy by dx at that point is 0, so like for example, if you are considering the tangential, so if it is 0 and d square y by dx square is less than 0, then it was actually condition for maxima. So the same way you can understand here as well. So here you can see, what about d square y by dx square? So here it is greater than 0. So which means R is positive here. So this will be minima. So if it is greater than 0, it is minima. So provided dy by dx is should be equal to 0 at that point. Okay, so this idea you can connect with your maxima minima, the maths concept. So we in physics also we use the concept a lot, maxima minima concept. And now one more example I would like to add here, that is, let's say I have an xt graph I have. Okay, so I consider an xt graph. This is my xt curve, that is displacement versus time curve. And this is the curve, suppose. So I'm giving a random curve over there. So I want you to find out what would be the, look at this, what would be the radius of curvature at this point? What will be the radius of curvature at this point? By using the equation. Okay, so you just pause the video and give a try, give a shot, and then come back. Okay, I hope you had a chance to solve the question. So now what we are going to do is, we are going to find out what is the value there. So here you know that x is basically a function of time here. X is a function of time, as you can observe from the graph itself, right? Yes. So now what is dx by dt generally? Dx by dt, it's velocity, v of t. And what is dv by dt? Which is d square x by dt square. That is the second derivative of displacement, which is basically acceleration a of t. Now we have radius of curvature equation, R is equal to 1 plus dy by dx the whole square, square the whole raised to 3 by 2. So instead I would like to make dx by dt, because it's dx by dt x versus t curve here, the square the whole raised to 3 by 2 upon d square x upon dt square. So this is fundamentally 1 plus v square the whole raised to 3 by 2 divided by a. So I would like to consider acceleration, the modulus of acceleration alone, because I want the positive value of radius. So I hope you understood this part. It's pretty easy, right? So I don't think it hurts you a lot. It's a very basic equation. You can just remember the equation, and I derived it in the last video. I hope you have got it. And now we will see, by using radial acceleration, if velocity at a point and radial acceleration both are given, by using the idea of radial acceleration, we are going to find out radius of curvature, and the application of that, couple of questions are there, we will discuss in later. Okay, thank you.